I'm Alicia Hawkins, and I'm really, I will say on behalf of my team members, thank you to the Ottawa chapter of the OAS for inviting us to present the work that we're going to be laying out tonight. I'm really privileged to work with all of these people and very grateful to them for all of their contributions. So our paper is entitled Alphabet Soup, because we're using a bunch of different methods that have lots of short forms. And I sort of like the idea of soup because we're looking at pots. So we'll begin with, let's see, hopefully I can get my thing to forward. Land acknowledgements. And so I personally would like to let you know that I'm grateful to be speaking to you tonight from Sudbury, Ontario, which is in the traditional territory of the Anishinaabe and is in Robertson Huron Treaty Territory of 1850. And I think my co-authors are going to let us know where they're speaking from. We're all from speaking from Turtle Island. So maybe Amy?
Sure. So I am in London, Ontario right now, and it is located on the traditional lands of the Anishinaabe, Haudenosaunee, Lanhapawak, and Attawandaron peoples on lands connected to the London Township and Sombra Treaties of 1796 and the Dish with One Spoon Covenant Wampum. This land continues to be home to diverse Indigenous peoples, whom I recognize as the contemporary stewards of the land and their own cultural properties.
Louis?
Yes, bonsoir, good evening, everybody. My name is Louis Lesage. I'm speaking from beautiful Wendat, Quebec, home of the Huron-Wendat, actually. So the homeland of our beautiful nation and our beautiful territory, which is called the Neo-NCO. Greg?
Hello, everybody. I'm speaking from Hamilton, which is the traditional territory of the Haudenosaunee, Attawandaron, and Anishinaabe.
Okay, thank you. So we're going to be talking tonight about a community-based project. And community-based, community-driven, collaborative projects, these are things that are talked about in vogue a lot these days. And I want to start by relating a personal anecdote that's become kind of lore in my family. So a number of years ago, I was at a family gathering at a kind of a cottage. There were a whole bunch of us there. And partway through the weekend, my dad's girlfriend pipes up and she says, "I have a good idea." And then she proceeds to outline this complicated scenario whereby my partner and I would drive her car to Toronto and pick up some things, move some things around, drop it off here, do this, that, and the other. And so she finishes, and then there's a bit of a silence. And my partner says, "Well, that's an idea. I don't know if it's a good idea, but that's an idea." And this is, something that has been repeated many times in my family since then. And I relate this because in my early attempts, I guess, to do community-based research, and in some of the projects that I see coming past my desk, I feel like there's a little bit of that going on. So that there's been a real effort in the last, I would say, 10 or 15 years to be more inclusive and to be talking to communities about the research that we do as archaeologists. But in many cases, I think it would be arguable whether those are truly collaborative projects because they have a little bit of this, "I have a good idea," right? And so for us, really, a collaboration is something where there's a co-conception, where there's an openness to ideas coming from everywhere, and where the questions are not necessarily questions that are conceived of by archaeologists. So in this particular project, we're looking at different knowledge bases, right? So we do have archaeological knowledge that we're generating, which we're going to describe in probably more detail than you're going to want. But we also recognize the absolute importance of traditional knowledge and how that has a long and important history in Indigenous communities, including the Huron-Wendat. And so we started our project from the premise that both of these knowledge bases could really contribute to what we wanted to do. Did you want to add anything to that, Louis, or can I move along?
No, you can move along. I will jump in in 2 slides. Yes.
In 2 slides. Okay. Okay. So for many years, and archaeologists have been doing research on the Huron-Wendat, where Huron-Wendat were really kind of objects of their study. You know, we can look at this as a history of almost 200 years. And as archaeologists, a lot of this analysis was focused on pottery decorations and pottery types. These and some other artifacts were used to characterize the archaeology of the Huron-Wendat and other Indigenous peoples, and then to map out in space groups that were really just like constellations of artifact attributes, right? But then these were mapped onto ethno-linguistic groups, such as what you see in this image over here, where these artifact constellations become associated with groups and tiny dots in space, with lots of space in between that was apparently unoccupied. And we have to ask, when we do this as archaeologists, where, you know, are we reducing the ability to see dynamism, to see things like contact, and is our focus on small differences, meaning that we fail to see the larger picture? Okay, so is this the slide you want to jump in on, Louis? Or
Yes, please.
Okay.
Yeah. So from our point of view, from the Huron-Wendat point of view, we have never been comfortable with the pot decoration used as labels to say, okay, this kind of decoration is a Seneca pot. So we were not comfortable with using those decoration to define ethnicity, to define a group. For example, these kind of labels are Huron-Wendat. Those kind of pots are St. Lawrence Iroquoian people. We, from our traditional knowledge, from our perception of who we are, we cannot be labeled by pots. You know, a First Nation, a group of Aboriginal people, is much more than a pot. It's not the way we should be described or defined. It's much more than that. So since the last couple of decades, archaeologists use pots decoration, pots color to define which Iroquoian groups are related to those kind of decoration. So recently, we said this cannot be a way to define a group. And a couple of years ago, I talked with Alicia and I said, you know, in Quebec, we have those archaeologists who are very strict to those labels, to those Aboriginal group defined by pot decoration. And in Ontario, we felt that the archaeologists are much more, have a more open mind, and they are much more receptive to our point of view. So I asked to Alicia, okay, would you like to use your perception, your lens, your glasses to look at different pots in Ontario and Quebec and try to see inside the artifact, inside the structure of the pots? Can we see much more than just the decoration? How can we look at pottery differently and try to see if we can use something else to understand the pot creation and how they were made and what's in it, what were the recipe that were used to build those pots, and to put aside those decorations that are used to define who we are. So that's the kind of question that we want to develop with archaeologists today, to use science to go further and to help us to find answers to our questions. Next slide.
Okay, so can I just say something? I was thrilled when Louis asked about this because this was like, wow, you know, okay, we can work together to try to do this, and so I realized pretty quickly that there are some excellent researchers who are working in a framework that would be really amenable to trying to understand pottery technology. And so I think Amy is going to come on next.
Yep. So we've been using the concept of a community of practice approach in this research. And a community of practice concept is sort of based in the idea that members of a community are created based on their participation in various tasks. And these communities are defined by a shared history of practice and the regularities of production and use in crafts, and not necessarily by spatial or ethnic constraints. So you can think about a community practice in terms of something like making apple pie. Some people use butter in their crust, some people use lard, some people prefer particular types of apples, which are sometimes dependent on whatever local produce is available. Some people crimp their cross edges in a certain way. And these sort of recipes and ways of doing things are often taught and passed down by people within a community. I myself always use a fork to press together the edges of my pie crust because that's how I always saw my mom make pies. However, it's not necessarily somebody who's related to you, who's teaching you and passing down these skills. So by using a concept of communities of practice as a framework, we are able to place technological decisions that are made by potters within a socio-cultural context. And this allows for the examination of traditions, patterns of learning, and the transmission of knowledge. In other words, sort of the tools of a trade. Constellations of practice, which is a sort of a concept that we're bringing into this research as well more recently, is a notion that allows archaeologists to examine distinct communities of practice that share a history or members or particular objects, or that engage in similar techniques or compete or share the same resources. So constellations of practice allow archaeologists to compare different communities of practice. And this approach recognizes that communities and constellations of practice can operate at differing geographic scales, which is handy in our work because it covers a very wide swath of land. So in total, this framework sort of shifts the focus from the pots to the potters, the choices they were making, and their engagement with both tradition and innovation, and away from those one-to-one correlations between pots and ethnicity or chronology. So I'm good there.
Could you play the video for me, please?
Going.
Thank you. So this concept of practice communities centers the technological processes associated with pottery manufacture as social practices. So the experience of a shared common practice is one of the ways in which people define themselves as groups and set themselves apart from others. And there's a great quote from a paper by Constellations of Practice that describes this idea in real terms. So when a mother sits down with their daughter, but never her son, to show her how to make a pot, they're not only making pots, they're also making what it means and feels to be a potter, a woman, a daughter, an apprentice, and a teacher. And so in this way, they're constructing identity. So each action that you can see in this video here, from mining the clays to mixing them, is influenced by a myriad of factors, including social ones, such as tradition. So we should view technological activities involving ceramics and the objects that result from them as fundamentally social in character. So in this way, we shift the focus from objects to people. So these pots may be one focus of this project, but really this study is not about pots, it's about the people who made them.
How much longer is the video?
No, it's okay, you can just go on.
It's interesting to watch her.
Yes. This is Maria Martinez. She's a famous potter from the Southwest.
Okay, we just got a couple more seconds here.
Yeah, that's fine.
Okay. Okay, so, oops, there we go. Back. Okay, so as Louis mentioned in the beginning, the Huron-Wendat don't see themselves as defined as a pottery type, okay? And so one of the sort of underlying questions in this is, are there connections across space? In Huron-Wendat oral tradition, there is a connection between the St. Lawrence Valley and the Huron-Wendat people. And so in undertaking this study, we wanted to ask, are there, what does the technology look like across space? So the St. Lawrence Valley, but also the place that's traditionally been associated with the Huron-Wendat because when European colonists arrived here in the mid-17th century, that's where the Huron-Wendat lived. And then also, how does this compare with what we find in Northern Ontario and Quebec? So in order to look at technology, we had to sort of narrow our sample universe a bit. So we decided that although we're not looking at decoration per se, we needed to, there's a really wide array of pots out there. So we couldn't sample all pots. And as you'll see, some of the technologies that we're using to do this analysis are quite costly. And so we could only sample a certain amount of stuff. And we needed it to have some basic similarities. So we decided to look at what's referred to as high collared pottery, which is illustrated here, and which interestingly is found in all of the 3 regions that we examined. So, and there are, although as I said, we're not concentrating on decoration, there are similarities in this decoration. So underlying dots and horizontals and triangular motifs and so forth. But so we narrowed the focus to high colored pottery, and because it's found in all of these places, and from a number of different sites across space, we sampled a small number of sherds. And one of the other kind of priorities of this project was to try to undertake this research in as minimally destructive way as possible. So that really meant doing collections-based research, going to places and asking what they have in their drawers. Thank you, Stacy, among others, to see if we could learn from what's already being excavated. So we use 3 different analytical methods, and they produce different kinds of data, and we're just going to kind of run through them quickly. So I've been working with a fabulous researcher by the name of Joe Petrus at the Harkai School of Earth Science at Laurentian University, using a method called laser ablation inductively coupled plasma mass spectrometry, which we shorten to LA-ICP-MS because it's a lot easier to say. So this is a way of getting the chemical signature of pottery, and it's fabulous because previous to this we were using neutron activation. And one of the difficulties with neutron activation in analyzing pottery from Ontario is that it's really hard to separate the clay from the inclusions. So what we do is this is slightly destructive. We take tiny little pieces of pottery and we embed them in epoxy, and then grind the epoxy down, and then this is placed in a sample holder with something that can blow up the image, and the little green dots show the places that are going to be sampled. And so this allows the analyst to really ensure that the only thing that's going to be examined for its chemistry is clay, that all of these other bigger things on the screen here aren't touched. So essentially, the way this method works is that the samples are placed in a sample holder over here, and then that's placed in the machine. And there's a high-powered laser that vaporizes a tiny spot on the sample. And then the gas from that vaporized sample gets sent to a mass spectrometer, and that measures the concentrations of different elements in the vapor. So there's lots of advantages to LA-ICP-MS. It's quick. You can do lots of spots in a single day. It's minimally destructive. In this case, we had to break off tiny things, but I've also been doing this with glass beads, and you can put the glass beads in whole and you can't even see where they've been sampled. And then it's really highly sensitive. So if you're looking for like diagnostic elements that occur in very low concentrations, you can detect them because it can detect into the parts per billion. And then finally, it can detect a really large number of elements. So on the periodic table that you see over here, all of the things in green can be analyzed. In fact, everything except that what's in red can be detected. So essentially, LA-ICP-MS is a great method for coming up with chemical signatures for pottery and excluding the temper. So the next one is Greg.
So we analyzed 77 samples using thin section petrography. So petrography works by mounting very thin sections of archaeological materials onto glass slides.
Your day.
And observations are then made through a polarizing microscope. So the primary advantage of petrography is that it bridges the gap between low resolution visual observations and the much higher resolution chemical analyses, such as LA-ICP-MS. So for the most part, we can actually see or feel the things that we are identifying using petrography. So petrography allows us to identify mineralogy. So if you look at that video, you can see as the stage rotates, things are changing in color. The dark brown stuff in the background is the clay matrix. Almost everything else is some sort of inclusion, some sort of a mineral. So the changes in color as the stage rotates and the angles at which the changes occur is just one way in which we can distinguish between minerals and by extension between rock types. So it also allows the examination of features that are related to ceramic technology, such as firing conditions or forming methods. Next slide, please. So a potsherd is a physical record of the choices made by the pot's creator. It contains evidence for decisions revolving around raw material selection, clay and temper processing and preparation, and the forming and firing of vessels. So mixtures of clay and temper manipulated in a certain way can be seen as recipes. And these recipes are in part informed by tradition. Next slide, please. Oh, there we go.
Okay, that's me. So I was able to scan in a micro CT scanner 74 rim sherds from these samples. And micro CT is a fairly new but very quickly growing field in ceramic analysis and archaeology. The scanner that I use for the analysis that you can see in the picture here is located at the Museum of Ontario Archaeology facility in London, and it's associated with Western University. And micro CT scans provide high magnification digital X-ray 3D images of the interior and exterior of archaeological artifacts. And they do this by generating a volume from individual projection images. So it really works in a similar way as a medical CT machine works, only ours is an industrial setup. So in a medical CT, your patient stays still and the detector and X-ray source rotate around. Here, our sample rotates around and our X-ray source and detector panel stay still, and it takes projection images as that sample rotates. We then use software to stitch those projection images together until we have a fully volumetric image of that ceramic. And image analysis software allows researchers to examine both a 3D rendering of the ceramic that you can see in this slide here, as well as slicing it along the X, Y, and Z plane, basically in any direction, in a non-invasive way. So we can basically slice into these ceramics without actually slicing them at all. I'm going to go to the next slide. So in 3 dimensions, we can isolate the clay from inclusions, which you can see here. Sorry, it's kind of slow. Those are the inclusions, as well as the air spaces or voids in the sherd. And this is all based on the density of these different materials. So here you see the void structures, and there's a big band of voids along the collar of that ceramic. So this makes micro CT a really great technique for examining ceramic manufacturing methods, because you can sort of follow those throughout a 3D sherd. Okay, that's good for me.
Good for you. Okay, so we have these 3 different methods that we're applying to a set of sherds from across Ontario, St. Lawrence Valley, and Northern Ontario and Quebec, in order to try to understand the process by which pottery was made in these 3 regions. And so each of the different methods can contribute different kinds of information towards trying to understand that manufacturing process. So the data set that we get from LA-ICP-MS looks like this. And I'm not going to take you through slide after slide in a giant spreadsheet, but this is basically what we get. And so it's concentrations of elements. And for each sample, we analyzed a number of spots so that we could see what the variability was within a single sherd. So clays are hydrous aluminosilicates, which means that the major elements in them are aluminum and silicon, but they're also may have as minor elements a number of other things like sodium, magnesium, potassium, calcium, and iron. and then a whole pile of trace elements like you saw in those in that spreadsheet that I just showed. And so our first question really was, you know, is there enough difference that we can actually distinguish between the chemistry of clays in different regions? And the work that I did a million years ago for my master's with neutron activation really didn't give me great hope that that method would help, but the LA-ICP-MS does seem to show that there are actually differences. And so if we look at just the minor elements, we do see some regional trends. So for example, iron tends to be more variable and often higher in Huronia. Sodium tends to be higher in the St. Lawrence Valley, and calcium is lower in the St. Lawrence Valley. And that's the minor elements. And we also look at a variety of trace elements, and those also show that it is possible to distinguish between regions. So there are real differences in elemental concentrations, and that really suggests to us something that shouldn't be surprising at all, which is that it looks like potters were using local clays in their regions. So in terms of clay procurement, appears to be local everywhere. Okay, Greg.
Okay. Yeah. All right, so we use petrography to identify the, oh, this is iron oxide, right. Okay, so one of the things that we can identify in a clay fabric using petrography is iron oxide nodules. And so you can see these, they are in the left-hand side, they're kind of a muddy brown. And in the right-hand side, there is a very large reddish one right in the middle. All right, next slide, please. And so while there is some variation, this variation is not statistically significant. So we can also look at silt inclusions, and here you can see two very different clays. So the one on the left, like the silt particles, are the tiny ones in the background embedded in the clay matrix there. Those are naturally occurring. The clean clay, on the other hand, on the right-hand side, you can see very few of these tiny silt inclusions. In both of them, though, you can see temper. And we know this is temper because of the high angularity of the grains. If you want to point a few of those out, Alicia. Very angular. So if crushed rock or gravel was being like pulled out of a riverbank, it would have rounded edges. And as we can see here, this is definitely not the case. So deliberately crushed. Next slide, please. So in Huronia, we see the clays are very silty. This is not the case in the north or in the St. Lawrence Valley. And the reason for this, we don't really know. What we need to do in order to investigate this further is to go out and collect some clay samples. And so we have begun that journey. So one of the main purposes of petrography is to identify inclusions or temper. And so by identifying a rock type by its mineralogy using petrography, we can also identify its color. So for example, every alkali feldspar granite is light pink. Every gabbro is black all over the world. It doesn't vary. So just as geologists today rely on mineral color to identify rocks in the field, 15th and 16th century potters would also have used color when collecting rocks for use as temper, if that color had qualities that they were looking for. And we'll get back to this in a bit. Next slide, please. So here are examples of felsic rock temper, and we can see lots of quartz, feldspar, and biotite. So these are all granite tempered, really. And again, you can see it's quite angular, so we know it's been crushed. Here we have intermediate rock temper, and we see a lot of, what we call mafic minerals. So hornblends, there's some pyroxenes, and a fair amount of biotite in the one to the left. So, next slide, please. So there's some difference between our study areas, but it's important to note that although it looks like a significant difference, it's not statistically. And as we'll see later on, there's a lot more internal coherence than there is between larger regions. So what we're seeing is a preferential selection of tempering materials. So felsic tempers, like granites, are overrepresented based on the regional geologies of the sites we sampled. So in all of these areas, there are loads of intermediate rocks. Primarily, that's what it is. A lot of this is a Canadian shield. Lots of intermediate rock and some mafic rock. There's also some felsic rock, but felsic tempers are overrepresented. So it thus appears as though people were putting some thought into temper selection. They were making decisions. So in Ontario, I can't speak for Quebec, but in Ontario, we see these same patterns of temper selection for pots in earlier time periods, from the 12th until the 17th century. So this appears to have been a long-standing tradition. Slide, please. Most interestingly, the types of temper used in pottery manufacture did not reflect the relative availability in the local landscape. So I'm not talking about the mineralogy, I'm talking about very broad categories. So fine-grained schists, limestones, and other sedimentary rocks were avoided completely, despite the fact that these rocks are common in each region, and they've been used in antiquity by potters all over the world for the manufacture of cooking pots. Further afield, some other materials that have been successfully used to temper pots, such as bone or fiber, were also completely avoided, although they would have been easily available to potters. Grog was commonly used in Upper New York State. Shell was found in Southwest Ontario, Upper New York State, and the Maritime provinces. Again, these are completely absent in our sample. And finally, crushed charcoal was used as a temper for smoking pipes. However, it was not found in any vessels examined in this study. So the choices that people made when selecting temper, therefore, appear to be geographically bounded and internally consistent across South Central Ontario and the St. Lawrence Valley. The differences seen outside these regions can be seen to reflect variations between practice traditions that serve to accomplish the same goal. So the goal is the production and the use of a durable cooking pot. So we see these converging technological trajectories, and each different trajectory is a community of practice. Okay.
Okay, so we've got our two things. We've got our clay and we got our temper. Next, we want to look at how those things were put together and then made into a pot. So LA-ICP-MS can contribute a little bit to understanding the degree to which the clay was well mixed, and also clay selection within communities. So the first thing we did was we wanted to see if the chemical composition of sherds from the same pot was the same. And that would suggest that the clay was really well mixed within that pot. And we can sometimes anticipate that it's possible that pots may have been built over time, and so slightly different clays may have been used for the bottom part of the pot than for the top part of the pot. So as I mentioned earlier, for each of the sherds that we analyzed, we analyzed a number of spots. Clays are fundamentally heterogeneous, so we never expect that the chemistries are going to be completely the same, and also there's going to be some instrumental variation. But if they're using the same clays, we should find that the compositions of the different pieces from the same pot do not separate, but rather overlap. And that's what we're seeing from this slide here. And then if we look at that same pot and compare it to other pots from the same site, we see that there is really fairly clear overlap. So it looks like they're using similar clays for all the pots they're making within this particular site, except for pot 84, which is a bit of an outlier. So it would suggest that the clays used in Huronia are relatively well mixed, and that the one part of a pot should be representative of the whole pot. So we don't need to analyze lots and lots of pieces of a single pot. What's interesting is that there's a little bit of a different story when we look at the one of the sites from the St. Lawrence Valley. And this is, so we did the same thing. We analyzed a number of pieces from a single pot. This does look the same as what we found from Ellery, which is that there was fairly good mixing. All of the spots are overlapping from the three different pieces. But what's kind of cool is that when we looked at different pots from the same site, those don't overlap so well. So this suggests that perhaps the potters were using slightly different clay sources. Not hugely, but possibly slightly. Okay, so next we want to look at what petrography can tell us about clay mixing. Greg?
There we go. Okay, so potters mix clay and temper in order to prevent pockets of inclusions, either temper inclusions or naturally occurring, from causing the vessel to dry unevenly and possibly crack. So poorly mixed clay fabrics can also cause problems further down the road when the vessel is fired or used to cook. All right, so if you look at these slides here, you can see there is, on the right-hand side, nicely, evenly distributed inclusions, very well mixed. And then on the other side, the clay isn't very silty, but there is a band that has a high density of inclusions sort of in the upper half of the frame there. Poorly mixed. Next slide, please. So there are some differences between our study areas. It appears as though the St. Lawrence Valley potters were spending more time mixing, or they did a better job, or possibly the clay just didn't require a lot of mixing. So this could be related to skill. It could be related to geology. Again, to fully understand this, we would need to collect raw clays.
Amy.
Okay. And in micro CT scans, we can also look at clay mixing, but it's sort of a much larger scale picture of clay mixing because the size of the sample I'm looking at for each sherd is bigger. So I can see, you can see in the middle image there where there's an area where temper hasn't been mixed through the clay very well. I was also able to notice clay pellets in other areas where clay hadn't been mixed, and that's a large clay pellet at the left there. There were also a number of vessels. That's it. There's a number of vessels where it appears as though a different type of clay, or often one that was less tempered or even maybe even untempered, that was used to form the outer surface of the vessel. Perfect, Alicia. So this may be that because potters were attempting to achieve a smooth surface on the exterior of these vessels. This doesn't always show up, but it does show up in a few of the vessels in these collections. Okay. All right, I promise we're almost done the sort of data part of this. But micro CT, the real strength in this method is the ability to sort of follow those void structures through the sherd. And you can see this is several sort of successive slices. And this tells us a lot about the rim manufacturing methods that were in use based on those internal voids in the ceramic. Next slide. So I found, I think, 5 different sort of types, although it's hard to sort of bunch them together, but I have as best as I can. The first of these were ceramics that had sort of large central parallel voids. And when I say parallel, I mean parallel to the vessel walls. So I think that these ones have clay or coils applied or smoothed onto the exterior. And these are found in all of the study areas and were the most common type. Okay, next. Okay, there's also a good number of vessels where there were perpendicular or oblique voids at the interior of the vessel. So those again are voids that are perpendicular or oblique to the vessel walls. And these look like they were coiled on the interior and then have a more solid sort of exterior layer that was either smoothed on or had a coil that was sort of pushed down the outside. And there's a video showing an example of one of these. And you can see here, once it disappears, how we can see how these different sort of coils were stacked on top of each other and pressed together by the potter. And essentially what I've done here is just segment along those void structures in the ceramic. So pulling those pieces of clay apart digitally. And then there was a couple layers of clay, either smoothed or foil added on the top and then smoothed down the exterior of the vessel. Okay. And then the next were very similar to that last type, and there's only 2 of these in the collection, where I think I'm seeing those perpendicular or oblique voids at the exterior rather than the interior of the vessel. So it looks like they've used coils sort of on the exterior and then smoothed some clay over the interior of the vessel. Next. And then I also had 2 examples where those coil breaks or those oblique voids go sort of right across the vessel. And I have arrows mostly pointing to the voids there. And then what you're seeing there in on the right, I guess, is a 3D rendering of those void structures. And you can sort of see that oblique orientation of the void structures in that ceramic. Okay, and the final one, there were 2 of these ones where, no. Yeah, there were only 2 of these ones as well, where I was not entirely sure what's going on in these ones, but there's sort of multiple parallel void structures that go down the vessel walls. And these could be layers of clay or very sort of flattened out coils being pressed together, but it was hard to tell what was going on. And these ones were both found in the northern study area. And here you can see on the map that there were sort of similar techniques being used to form these high collar vessels throughout the entire area. So those sort of layered, those 2 layers are shown in blue here, the 2 different colors of blue. And potters are using essentially coils and layers of clay in various ways to achieve this high collared effect. In the south, it's always two main layers that make up the collar and the rim of the vessel, except for one example that was just had the coils going right across it, located in Eastern Ontario. And the use of coiling to make up one of these layers was really spread fairly evenly across all the geographic regions as well. Okay, next, please. Micro-CT is also really good for looking at what I've been calling adaptive irregularities. I was calling them corrective measures, but I like the idea of sort of improvisation and rim forming. And it really gives us an idea of those sort of small little gestures that potters were using to form these rims. So I noted these on 35 of the 74 vessels that I scanned, and they included features such as little bits of clay added to the lip, pieces of clay added onto constellations, areas where the lip has been sort of smoothed over either from the interior or the exterior. There were some examples where there was a little bit of clay added to the base of the collar, sort of to thicken that very thickest piece of the collar. And there was also two samples where we had these corn motifs and they were added onto the exterior. So I really like that these show the improvisation and interaction between the potter and their materials. And we can see here on the map that these show up fairly commonly in the southern regions, but not so much in those northern sites. So there's only a couple, I think only one up north. Okay. So this is similar to Greg's tempers not chosen slide, and these are sort of some of the techniques that weren't chosen, but it's fairly limited because there aren't really many comparative studies of archaeological woodland ceramics where manufacturing techniques have been the focus. But the other micro-CT study we do have suggests that there are shared practices between the makers of these 17th century high collar vessels that we're looking at here that didn't exist elsewhere, and practices used elsewhere, but that weren't used in this context. So this slide shows a few examples of 67 sherds I scanned for my PhD. And these are from a cluster of 13th century sites in Arkona, Ontario, which is near London, Ontario. So it's farther west and also much earlier than our study. But it's still a good point of comparison. So in Arkona, potters were commonly using a folding technique to thicken the top portion of their pots. So you can see where the arrow is pointing, that's the top of a fold. And then there's a bit of clay added on top of the folded bit. And you can sort of see those curved voids in the other two examples that show folding. So I didn't observe folding in any of the pots in the current study. So in the Quebec and Ontario sample, I didn't see folding at all. So this is pretty preliminary in terms of examining Indigenous ceramic manufacturing broadly across what is now Ontario and Quebec, but this really shows that there are indeed differences between techniques being used by different communities of practice. Okay.
Okay, so what does this whole set of data help? How does it help us to understand communities of practice? And I think Amy really led into this well, as did Greg. So I guess the first thing that I want to kind of mention is that our whole project conception was one that allowed for the possibility of connections and shared communities across space, across the St. Lawrence Valley and Ontario. And but at the same time, we didn't set this up to be able to ethnic identity. That wasn't what we were looking at. We're looking at to try to see, are there connections between people that can be inferred based on shared practice. And what we found was indeed that there are a number of ways in which ways in which pottery is manufactured is shared, and that these do differ from pottery technologies in earlier periods and in neighboring areas. And so that suggests that there are connections, and it also allowed us to understand better the technical choices that are being made by the 15th and 16th century potters, that pottery is more than just the way that Sagard characterized it, is that basically, you know, they take a ball of clay and then they turn it into a pot. There are many important choices that potters make in order to execute their practice. I also want to talk about how this helps collaborative practice. So I think we're over to you, Louis.
Yes, thank you, Alicia. Yes, what I like about this this picture is that I see what are the basics of collaborative research with Amy, Greg, Alicia, and also Michel Plot. And this picture has been taken in our office in Wendat. And what we see here is a group of people, a group of scientific people that want to collaborate and to make research to, well, to better understand how our ancestors were living, to better know the life and times of our ancestors. And this is the main objective of collaborative research, is to use Western science and traditional knowledge and to put on the table a question and try to find answers using science and using, as you have seen in the previous slides, using high technology science to go forward, to look deeper, in this example, in pots. So what we learn from this is that we all learn from this study. Us, the Huron-Wendat Nation, of course, and the archaeologists, our friends that we have here on the picture. We all learn from this, and we also published a publication in our local journal, which is called the Yakwenra, because it's very important that our community, our people, also learn from these studies. So all of these leads us to a better knowledge, a better general knowledge, and it also helps us to take care of the circle of knowledge. The circle of knowledge is to help us to learn from each other, and then to increase the circle of knowledge, to then ask new questions and to put on the table new questions with these collaborators and to try to find other answers. So what we learned from this study is that there is a general recipe that is used in those groups of Iroquoians, let's say that, and the colors, the decorations of the pots can no longer be used to subdivide groups. It's more deeper. There is a community of practice from Ontario to the St. Lawrence Valley that were sharing the same recipe. The same recipe as the recipe to make an apple pie. You know, when I use the image of an apple pie, everybody knows how to make an apple pie. But from regions to regions, some people will use green or red or Macintosh apples. Some will use more cinnamon. Some will use more or less sugar or flour. But you need to have the basics to do the apple pie. So what we have learned here is that there are basics that need to be known to build those pots, and that's very interesting, and that goes in the same way as our traditional knowledge, which is we cannot be differentiated, or we cannot be labeled only by a single factor on pot, which are the decoration in this example. Next.
Okay, can I just add something? Which is to say that from the perspective of an archaeologist, I think that this is a really enriching experience because we're really forced to move outside of our comfort zones and to start to think about how we can analyze things in different ways and to sort of put aside some of the things that we consider to be basic truths, right? So you know, I don't know that we would have put together these three methodologies to try to understand pottery technology had we not been really asked to do so by the Huron-Wendat Nation. So we are still, we're not done. We're never quite done. We're still doing a couple of more things. One is that we're working, one of the members of our group is Richard Zane Smith. And so Amy has kind of outlined a bunch of different ways in which these rims were made. And so now those are theoretical. So we're asking Richard to see if he can try to make rims that actually work using those methods. So that's a bit of a test. And we've done that using Atherley clay. So this is clay that comes from very close to one of the archaeological sites in Huronia. And which Richard thinks is actually really great clay. So that's one thing that we're doing. And the other thing that we're doing is one of the important aspects of this project is to ensure that the communication about it doesn't just go to archaeologists and doesn't just get published in obscure journals that you have to pay $50 an article to get, but that the communication is open and that it's done for the community as well. So there's a science communication program at Laurentian, and they've been working on development of a couple of prototypes that will be part of an exhibition on the project. That exhibition is going to happen at Dynamic Earth in Sudbury, and then also at the Huron-Wendat Museum. And they're looking at one of the aspects of this is to sort of try to get people to see how micro CT works by making their own pot and then cutting it to see if they can see the places where the voids are and what inclusions look like. And also to look at this, I think this is a great question, this sort of destructive nature of archaeology. So after they've built a pot, then they have to cut it open. And so then they're faced with this, like, what's my feeling when I cut a pot? So anyway, so these are things that are still in progress, but we should have done fairly soon. Okay, I want to end by mentioning a number of the other people who've been involved in this project, but who aren't like presenting today. So Melanie Vincent from the Huron-Wendat Nation, who's helped with communication, Richard Zane Smith, this fabulous Wyandotte potter, Alison Bain, Michelle Plourde, Katie LaBelle, Chantel Barrio, Amy Henson, Jennifer Beaudry, and students from Science Communication, Neil Ferris, and Valerie Roussel from the Huron-Wendat Museum. So we also recognize SSHRC for funding us. This wouldn't be possible without SSHRC funding, and the various facilities who helped, and a very large number of people and institutions who've assisted by loaning us artifacts for analysis. So thank you to all of them.